Hello, everyone. Good afternoon. This is Matt Jones from Miller 3D. Just want to get a mic check, make sure you can hear me, and we'll get going in a minute or two. So if you can hear me, if you could just type in the questions area that you can hear me, that would be great. Okay, great. We'll get going in a minute or two. Let people join up here.
Anthony, I think you might want to mute your mic in the meantime. There's a little bit of reverberation going on your side.
Yeah, that'd be great. Okay, we're going to get going. Welcome to our webinar. The Future of Additive is now with Composites. This is Matt with Miller 3D, and also on the line we have our engineer Pat Harrington, as well as Anthony Barrick down in our Harmony PA office. What we have scheduled today is a quick presentation by myself, and then we're going to kick it over to Pat. He's going to go through a software demo, and then after that we'll go to Anthony, and he's in front of the machine that we'll be talking about today, and he'll go through a live demo of the machine. Just quick housekeeping things. If you have any questions in you can type them in the questions area in the Go to Webinar tab, and then we will see them, and then we can get them answered. Likely at the end of the presentation, but we'll try to get to them as they come in. So we're Miller 3D. Miller 3D is a reseller for 3 different manufacturers. One is Big Rep. The other is 3D Systems, and then the other one is Markforge. And each one has their niche. If you take Big Rep, they're more for the large format 3D printing, and we're talking up to 40, to 60 inches of part length, and that you could 3D print. If you go to 3D Systems, they have a wide range of technologies, ranging from very small little intricate parts all the way up to very large, and also into direct metal printing with the laser and the metal powder. And then Markforge is unique as well. They have their own technology, mainly focused on composites, as well as metal 3D printing. And we're going to talk about composites today, and we also have a webinar coming up on Thursday that we talk about the Markforge metal technology. So please tune in for that. And we'll talk about Markforge. Markforge has been shipping machines since 2013, and they've really been on this high trajectory of innovation and and really developing unique technology in the 3D printing market. And really, their claim to fame at the very beginning was reinforcing a part with continuous fiber, and that's really what we're going to focus on today. However, where they started off really small with a handful of people, they've really grown into a powerhouse of over 350 people, 6 different 3D printing composite platforms, and then 1 metal 3D printing platform. And they're coming out with a lot of next generation things like artificial intelligence that's built into the software and works right along with the hardware, meaning the 3D printer. So they're really becoming an innovation leader in the 3D printing market. They have a very comprehensive material portfolio that we'll go over, and really their niche, their mantra, if you will, is strong parts. A lot of times in the past, FDM style printing would yield on the weaker side of parts. They were good to get a part in your hand. However, you really couldn't use those parts. And where Markforged fits in is the high strength parts, and we'll talk about those as well. Accessibility, easy to use. You'll see when we go over to Pat and he talks about the software platform. And also with Anthony, he'll get you in front of the machine. You'll see actually how easy the system is to use and to run efficiently. So we look at the printing platform. Markforged has 3 unique deliverables with the hardware, the actual 3D printer itself, the materials and industrial materials, and then the software platform really to make it all run. And they all work together seamlessly. Another big thing about the software is that it runs their entire fleet of their 3D printers, whether it be composites or metals. You have one 3D printing software platform. So the materials, if you think of the plastics as your matrix material, now the plastics is either going to be what we call an onyx material, which is a nylon that has infused chopped carbon fiber in it. So short fiber carbon fibers that are infused into nylon. So that's your plastic matrix. And then the other materials, as far as the plastics are concerned, you can do a straight nylon 6. And they also have a UL94 V0 flame retardant onyx material. And we got a cool video on our website. If you want to check it out, we actually light things on fire, which was fun. Then we get into composites, and this is really where the unique IP comes in for Markforged. They were the first ones to do this, and really, I'm pretty sure they're the only ones even today that can do this. And if you think of on the inside of the parts, we're reinforcing the part with a continuous fiber, and that's the key word there is continuous as opposed to the short fiber. This is long and continuous. And then to further on, they have metals. They have a whole lineup of industrial metals that they're 3D printing on the metal machine. And like I said, if you want to come back on Thursday, we'll be talking all about that. So the picture in the background is a really powerful analogy to what is actually going on the inside of Markforged parts. If you think of the concrete as the matrix material, the plastic material, which is what we were just talking about, And then the aggregate in the concrete, all the pebbles and stones, are the short fibers inside the onyx material. And then what really makes concrete strong is the rebar on the inside of the concrete. And now the rebar is analogous to the continuous fiber that's reinforcing the part. So it's a good analogy to kind of get in your head what exactly is happening on the inside of the part. So when we take a cross section of a Markforged part, this is what you can expect to see. On the outside, the black material here is the matrix. This is your chopped carbon fiber. Then routed on the inside, and this is where the software comes in, is your rebar or the continuous fiber on the inside of the part. And what it yields is a very, very strong part. When you look at it on a flexure basis, when just the onyx itself. So let me back up. Most of the popular materials out there are ABS or PLA. There's a lot of 3D printers that will do that. If you just print onyx alone, it has a higher strength and stiffer than ABS, and also PLA is down here too. And then look what happens when you begin to reinforce the part with any of the 4 continuous fibers. So we have carbon fiber, we have a high strength, high temperature, we have regular fiberglass, and we have the Kevlar. And these are compared to 6061 aluminum. So if you do a lot of aluminum machining, whether it be for tooling and fixturing, you can start to look at these materials now as a replacement or a substitute for those machined aluminum parts. And it's a powerful thing to offer that as a replacement, mainly because machinists and tool makers are very hard to find, and the tool room is usually backed up. The fixture makers are backed up. So it really should not be feared by the skilled trades and the people that work in the industry. It should really be adopted as another tool in the toolbox, and it could be a very powerful complement to what they do. So there's a video out on YouTube. What Markforged did, they 3D printed a chain link out of carbon fiber. You can see the carbon fiber routed throughout the part, and then they tried to break it. And it took 22,000 pounds, a little over 22,000 pounds to break this carbon fiber. Really to reinforce, no pun intended, reinforce the idea that these are strong parts that they're creating out of their 3D printer. Because there was a notion in the past that 3D printed parts were not strong. And that's where really Markforged is trying to change that dynamic. So there's just a little fun slide. What is 22,000 pounds? Just to get an idea of how much that continuous carbon fiber, can withstand. So this is a couple of examples of what some of our customers are doing. This is a mold shop that really, I think, took it to the next level. Is they have 6 Markforged printers in a rack system here, and it's tended by a cobot. And then on the sides here, you can see the build platforms that the cobot is interchanging out with the finished parts, and then loading in a new build. Even has a status light here, which I didn't notice. And then also the cobot's actually operating the printer. You can see a little stylus in the gripper that it's actually running the printer, which I think is really cool. So what do they do to do this? Why would you need it? Well, they run all their CMM fixturing on these machines, and they also have a product line. So this is talking about, production now. These are end-use parts. Not only are they used for tooling and fixturing, they're actually selling the parts that they're getting off the Markforged 3D printer. So this is a mount for a telescope that they make. Over here is a cross-section of the part, and you'll see in the software that you're able to design these cavities. And what you can do is pause the printer at a certain layer height, and the machine will email you, and then you could come over and insert your inserts. In this case, it's a threaded T-nut here, and then you resume the print, and then it encases your insert inside the finished part. So you can see over here, these are the metal inserts on the underside there. This is another one of our customers here, and if you have tin cans in your house, chances are it went through Reynolds Services. And what they do, they have these lines and lines and lines of tin cutting and slitting machines. And these machines are quite old, so they do break down. And after a while, it was very hard to find replacement parts. And a lot of times they had to buy different parts and then remachine them, to fix these machines when they go down. So they adopted the composite as well as the metal technology. And here you're seeing a part off their metal technology, from Markforged, as well as a composite. So they could keep these lines running with minimal downtime. So you see here, this was a metal roller that eventually wears out, and they're replacing it with a carbon fiber roller. So it's a direct replacement, from metal. They're replacing it over with the carbon fiber because it has good wear characteristics. And then they're pushing in a bearing at the end. And they have this table set up. I mean, they've really adopted additive throughout their whole facility. And they're doing things like, pulleys, also motor mounts. They have new motors going onto these machines. They 3D print the motor mounts. And they just do the standard Markforge soft jaws. I mean, we've been doing these for years, and it works. It works great. It keeps your mill or your lathe making parts as opposed to making fixtures. You want to keep your CNC machines running on producing parts and not the fixtures. And by the way, this material is great, for parts and material like this because it's non-marring. It doesn't mark up your parts if you have sensitive surface finishes and things like that. So before I kick it over to Pat, I just wanted to go through a couple of training offerings that we have. We focus on, of course, we sell the machines, but we also focus on the training aspect. And this is either training before you get into 3D printing or even after. And really the focus is on how to design for additive manufacturing because it's different. It's much different than designing for your traditional manufacturing. So we have these courses set up. We have plastics, composites, we have a metal, we have a business owner. We also have a custom course. We could come on site, or once things begin to reopen, we'll have some dates set up here at our office. Markforged also has their own university. It's the Markforge University. This is more guided instruction after you have your Markforged machine in-house, whether it be on the composites or the metal. and they train you how to design for their technology. You can go up to Watertown, Massachusetts, and take part in their training, or they can come to you as well. So I think with that, I'm gonna pass it over to Pat.
All right. Thanks, Matt.
Yep.
Let me just take the screen here and do my usual check to make sure that you can see it.
Yes, I can. Got it.
Okay, thanks. All right, so I'm going to take you through Markforge's IGER software. And all 3D printing technologies, all 3D printers have a slicing software that we use to process our CAD files through in order to tell the printer how to make your parts. In Markforge's case, they use a cloud-based solution that's called IGER, and this is going to service all of their different platforms that they have to offer. So it's going to service the desktop and industrial composite machines, which we'll talk about in depth today, as well as the metal machines that we'll talk more about in our next webinar on Thursday. So what we're going to do is start off with an STL file. This is basically the standardized file format for almost all 3D printers, and any type of CAD software will have the ability to export out your file as an STL. So you'll go ahead and you'll import it into here. And then once that's done, you're going to come to this screen, you're going to get a visual representation of your file. And you're also going to get a grid layout, which is basically going to tell you how big of a part you're able to do depending on the machine that you're setting up for. So what you're seeing here, this is the build envelope, this grid here for our X7 machine that we have in our offices. This is under the industrial portfolio. And then we also have the desktop series that you're seeing here. But let's talk about this part. So this is a real life part that we've actually used and made. We were in a situation where we needed to remove a solenoid valve from a different type of machine, and we found out, that we needed a spanner wrench. We didn't have one. Rather than wait to order one or to go searching around for this specific size, we just modeled one up in CAD. We designed in a through hole to have a dowel pin pressed in. And we just said, well, since we can reinforce this part with continuous fiber, we know it's going to be able to be strong enough for what we need it for, so let's just print it and have it by end of day. So that's what we did. It ended up being around a little over a 3-hour print, costing just around $7. So you can see that's probably a lot less than you'd be able to purchase it for. Let's go through the settings that you have options to change and tweak as you're setting up your parts. So the first obvious one is your material, and this refers to the base material or the matrix material. And we have 3 options as of right now. We have our onyx, which is our nylon 6 that's impregnated with those chopped carbon fibers. We have a specific blend of onyx that's FR, flame retardant. And then we have a nylon white, which is just your nylon 6/6, no impregnated fibers. But most people stick with onyx. It prints the best, great surface finish, awesome dimensional accuracy, nice and strong even without fiber. So for most applications, we do use that. And then if we do need that added strength, we move on to the next option here, which is reinforcement material. So certainly not mandatory, but if your application calls for it, you can incorporate in your fiberglass, carbon fiber, Kevlar, or this high strength, high temperature glass for more under the hood applications. Okay. You already saw me change my printer type. This is really just going to dictate the size of a print that we can print. And manual rotation, there's a few different ways to orient parts on this plate. Say for example, your part came in like this. Maybe you designed it on the right plane instead of the top plane. Well, you can just as easily click on the surface that you'd like to be down facing, and it will snap. And then you can use this orb here to orient your part however you'd like. So pretty simple stuff for part manipulation, orientation, material-wise. Then we get into the settings. So the first option here is layer height. If I go back and I say, no, I don't want to use any continuous fiber, well, then you'll see that this option becomes unlocked and we have some flexibility to play with. And we can print this part, as long as you're using only onyx, in several different layer heights. This is really going to dictate the vertical surface quality of the part, as well as the time it will take to complete. So on the industrial series, we can go down to 50 microns, so that's 2 thou layer height, really detailed, smooth surface finishes. Or if you're really optimizing for speed, within the last few months here, because this is a cloud-based software, they pushed out a new feature to Gen 2 X7 customers, which is this 0.25 turbo mode, and then you can crank through parts. It prints a little bit thicker, but it also does a few different clever things with the way it prints different features to really ramp up cycle speeds. So if you are going to be using one of the continuous fibers, well, that option now becomes locked because we're constrained to whatever thickness fiber that we're using. That kind of dictates our layer height there. So supports, this is something that the software will automatically generate supports wherever those are needed. And then you can take a look at where those are going to be put. The way that this technology generates supports, you'll see a little bit more on the next screen, and they're very easily removed after the print just by manually pulling them away, breakaway supports. We have some other features here that are just to aid in different geometries. We have 2 options here, this turbo infill and turbo supports option, which they have beta next to them, so these are kind of to be considered experimental print settings that we've had a nice degree of success with. And again, it's just going to help you increase your cycle time. It's going to, or decrease your cycle time, decrease print times. Turbo infill. So what is that actually referring to? Well, it's referring to how the inside of the part is printed at which speed. So when we talk about infill and printed parts, if we were to take a cross section of this part and look on the inside, it's very rarely going to be a solid part, like an injection molded part. What you're most typically going to see are these different infill patterns printed on the inside. And this is to save material costs as well as decrease print time without compromising too much in terms of strength. And that rings true especially with Markforged, because since we have the ability to reinforce with fibers, infill doesn't really take the load on the parts. It's really the fibers that do that. So the infill is really just there as a scaffolding. We have a bunch of flexibility as to what fill patterns we want to use: triangular, hex, rectangular, or if your application does require it, solid is possible to do. I tend to like triangular. It seems to be a nice balance between speed, dimensional accuracy, and strength, but each of the fill patterns will have a different density range that you can achieve by just playing with this bar here, which is going to really dictate how packed in these fill geometries are. And then we get to roof and floor layers. This is really going to dictate the surface finish on the top and bottom of your part. And then wall layers right beneath it is going to dictate how many passes the nozzle will do around the perimeter of your part. So by default, it's 2. Our nozzle width is 0.4 millimeters. So 2 passes of those. If maybe you have an application where your part is going to be on a wear surface, it's going to be rubbing against metal, well, you may find that bumping that up a little bit to 4 will just give you a little bit of a thicker shell before you start wearing into the infill that we discussed earlier. Okay. So our last setting here before we get into more of the internal view settings is the reinforcement tab. So if you're using fiber, that will become available. And you're going to tell the software how many layers you'd like to incorporate the continuous fiber in. You're also going to tell it how you'd like it to print that continuous fiber. So we have 2 options, being concentrically or isotropically. And in this case, This is a textbook application for concentric fibers, which is going to route those fibers around the perimeter of the part, kind of spiral in on itself, as those add quite a bit of strength in applications just like this, where the wrench is going to be torqued, rotationally. Concentric fibers add a lot of strength rotationally around this vertical z-axis perpendicular to the plate. The other option, isotropically, is great for parts that need to be resistant to XY bending. So think of more like a beam or a cantilever bending. This is going to allow us to simulate more like those composite layup sheets of woven fiber. And it's going to give us really nice directional strength in the whole XY plane. So I'm going to show you a different part that utilizes that in a bit. So we'll focus on this one for now. Last two options here are, which walls would you like to reinforce on your part? Sometimes it's fine to just reinforce the outer shell, but you can also only reinforce inner holes, like bolt holes. You can also do both. So those are both options. And then lastly, how many concentric passes would you like to do with your fiber? This is going to dictate really the strength. And that can be tweaked here or at the next screen, which I tend to prefer because we can get into the visualization a little bit more. So normally what you do is you'd hit save, and then we can go into our internal view, which you're seeing here. Below, you're seeing our part, what's going on in the inside of our part. In blue, we have our continuous carbon fiber. And then down here, we have what's called our layer timeline. So this is showing us the beginning of our part all the way through printing to the end of the part. So if we click on the blue band here, you're seeing how it's going to route continuous carbon fiber concentrically, which layers that's going to occur on, so layers 5 to 8. The software is automatically going to try to populate fiber at the top and the bottom of your part because that is where loads are most concentrated. But if that's not something that you want, you can certainly edit it. And editing the way that it prints fiber is very easy. So you can do so by clicking on the band. Right now we have 2 concentric rings of fiber. Maybe you realize that your application calls for a little bit more strength. We can increase that up to, say, 6. Now we have quite a bit more fiber there. So that's one way to add strength. Another would be to increase the amount of layers that the carbon fiber is used on. So we can click on that band again. It's 4 layers of carbon fiber. We can just as easily drag our arrow and increase that to 10 layers of carbon fiber, layers 67 to 76. And it will populate those layers. If you want to add fiber in areas that are not just at the top and the bottom of the part, you can also do that very easily, which is clicking and dragging and holding on layers you'd like to incorporate fiber in. We have 6 selected. Coming up to just use fiber, create a group, and then it will draw those in. So in addition to this 3D view that you're seeing here, we can also go into a 2D cross-sectional view, and we can get a play-by-play on what the printer is going to do every single layer of our part. So here is the first layer. These squiggly lines you're seeing around some of the areas is support material, and that's really just because there's a fillet on that bottom edge. So as we scrub through the part, we're going to see carbon fiber in our triangular infill pattern. Start around layer 5. We're going to keep going through our part. Here's that middle band of carbon fiber I just incorporated. And then our through hole, where the dowel pen will be pressed in, is also going to have this support material. This is going to be very easy to remove afterwards. Sometimes you'll just need some meat on those pliers to get into holes to pop those out. And then it will round out the rest of the part until it completes. Now, one thing I wanted to mention that Matt brought up is the ability to program in pauses for any type of hardware that you're thinking about inserting into your parts. So this is something that we've certainly done with success. We've modeled in cavities for nuts We modeled in cavities for magnets, pressure sensors where we leave the lead sticking out of the side of the part, strain stress gauges, RFID tags. So it's really just you modeling in a cavity into the part. Coming into this 2D view, you're going to find the last layer before it's going to close off that cavity. And then we're just going to click pause after layer up here. See this nice box show up where that's going to occur. And then about 2 hours and 9 minutes into our build, this will stop, will pause itself. If your machine's networked, you'll get an email saying that that's occurred, so you can go over to the machine. You can pop the whole plate right out of the machine, put any hardware inserts in that you'd like, replace the plate, and resume the print to encapsulate those right in. So nice and easy, it's seamless. And it's an option that's not available on all types of 3D printers, so somewhat unique to Markforged. So once all of these settings have been selected and we're happy with the way it's going to print, happy with the way it's going to reinforce the part, we'll hit save, which it will do its final slice. And then we'll finally be able to bring it over and send it over to the printer. So if I zoom out, here's our industrial printer here, and here's our plate. This is really where you're going to decide where on the plate you'd like your part to be. And then this is also where you're going to be able to add in other parts. So, you know, they don't obviously all have to be the same part. They can be different parts. They just all have to be sliced at the same layer height. We will get an updated print time based on how many parts you have in there, an updated material cost. And then what we can do is find our printer, select which one we'd like to send this to, hit print, and then we can add it to the queue. Or if your printer is not running and it's just sitting idle, unlike ours right now, you can actually just send it right to the printer without even having to walk over to it. So some cool features with the cloud-based software. We can also jump on to our printer in IGER here, and we can look at photos that the printer will take every 5 layers if you have an industrial series machine to kind of check in and see how the machine's working. So a lot of monitoring availability. You see our print in the Buffalo office is just about finished in about 14 minutes, and then we're going to load it up with another one. Before I kick it over to Anthony, let me just backtrack a little bit and show you another part that utilizes a different fiber as well as a different fiber reinforcement strategy. So this is a end-of-arm gripper that picks up castings for a company called Dixon Valves, and the castings are moved with these grippers to different machining centers for cleaning up. What they found is Kevlar is a great fiber to use in this type of application because Kevlar is going to give you the best impact strength. So if these things are taking a beating, you know, banging into stuff, if you want your parts to have a little bit of give to them, and then actually go back, you know, give a little bit and then flex back to where they, as designed, that's a great use for Kevlar. And these are set up for isotropic fiber inlay, and you'll notice it looks a bit different than our spanner wrench. We get a bird's eye view here. You're going to notice that we're still seeing our concentric rings of fiber around the perimeter of the part, but everywhere in between, we have something new going on here. So let's take a closer look at the 2D view. In between our concentric outer rings, we have this nice zigzag pattern of fiber, and this pattern is going to alternate every layer. So on our first layer here, it's at a 0-degree angle. It's going to switch to a 45 the next layer, then to a 90-degree angle, and then 135, and then back to 0. These angles can be whatever you'd like them to be. You can set, 57 degrees if you want something goofy. You can also have it alternate only between 2 angles. It's really customizable however you'd like it. So again, this is going to give it great strength in bending. It's just another option for setting up parts for your application, depending on how they're going to be loaded. And the software, as you can see, it's fairly intuitive, pretty easy to jump into. And with that, I think I'll pass it over to Anthony. If you have any questions on the software side, be sure to put those in the questions box, and we'll make sure to get those answered.
Thanks, Pat. I really appreciate it. Can everybody hear me okay?
Yeah, I can.
Perfect. So before I move the camera here, while we got it set up on this print here, there's a couple things I want to point out. Pat right there at the end kind of touched on being able to monitor the printers, and he pulled up the list of printers that we have, and he showed what we were printing in New York. And you know, what's really cool about that in the IGER software is the ability to send printers or prints to any of the printers that are on your network, right? So the part that's actually printing here is actually a couple of different parts. I had the printer ready here in PA, and Pat actually sent this print. He prepped it in the New York office and actually sent the print down here to the PA office to print, because we knew that this printer was available. So if you work at a company and you've got multiple different sites, or you're going to have multiple printers at different sites, or if you just want to send a print to a printer and you're not on site, as long as your printer is set up and ready to go, that's something you can do, and that's really cool. The other thing I want to point out is, while we have you know, the angle looking down on the machine here, is what makes the Industrial Series X7 from Markforged really special. So the first thing you'll notice is on a lot of the motors here, we have encoders on all of the axes of the motor of the printer. And the reason that is important is for accuracy and speed. The Markforged X7, using the encoders, doesn't have to home every so many layers. The printer knows exactly where it is the entire time during the print. The other thing that's really important about the chassis of the machine is, you'll notice that the entire chassis is machined aluminum, and it's a really rigid X and Y chassis on the X7. And the reason that is important, again, is for accuracy. The printer is only as accurate as the machine can be rigid, and the machine just screams quality when you look at it. Everything is machined, everything's polished, everything's finished, and it's really nice. The other thing to point out is just how maintenance free this machine is. On the X7, essentially the only maintenance items you have are keeping the slide greased, as well as keeping the belt tensioned that does the X and Y travel on the X7. And other than that, that essentially is about the only routine maintenance item things that you need to do on the printer. And even those are 3 to 6 months things to check. So it's a really reliable machine. It's really nice, really good quality. I just wanted to point that out before we, back the camera out and kind of show you a view of the overall system. So give me a quick second here. I'm going to move the camera back so everyone can see what the entire system looks like. All right, there we go. That'll work pretty well. So this is the Markforged X7. This is the entire package for the machine. So it's really an office-friendly machine. The machine runs on 110, so you can plug it in your cubicle, run it on an office desk, or if you have a shop space, that'll work too. This is the build chamber on the top. The material is held in the bottom. If I open this up here for you guys to see what's on the inside here, this is mostly where we keep our extra spools, as well as the spool that the printer's printing from. So Pat had mentioned some of the continuous strand fiber. This is one of the spools for a carbon fiber. So this is our large 150cc spool for carbon fiber. It also can do the 150 in all of the fibers, the Kevlar and the fiberglass as well. Inside the bottom of the machine, we also have the dry box. So this is where your plastic onyx spool is kept. So we'll open that up. And that's what the spool looks like. It's a 800 cc spool of onyx filament. The filament runs out the dry box to the back of the machine where it runs up into the top of the build chamber. It'll come through, out into the nozzle. The actual fiber filament is loaded on the inside of the machine, and it as well runs up through a Bowden tube along the gantry and out the print head. So it's a single print head with two nozzles, one for the plastic and one for the continuous strand fiber. You do want to keep the dry box closed just to keep moisture out of your material. One thing I also want to point out is some of the parts that we have on the table for the X7. So Matt kind of touched on it a little bit. He talked about a lot of the applications, but just here at our office, just for contract printing and some of the work that we do, the amount of the wide range of applications that we have. One of the more common ones, something like CMM fixturings like we have here. This is a common application we do where we can 3D print the fixture for parts that are really complicated to hold. Matt talked about it a little bit, but I want to also point out the ability to coat parts. So we have an onyx part here, and then we have that same part, which is Cerakoted in a flat dark earth color. So that's a common application. And then another application that's really interesting, we do CNC equipment here as well. And a lot of times we get contracted parts for people who are going to machine a part, but they either don't have the soft jaws or the soft jaws are complicated. And we have the ability to 3D print those jaws so that we can actually do multiple setups on a part in a single set of jaws. So it just goes to show that it's not just prototyping. We can do end-use parts. We can do custom tooling. We can do prototyping. And we can also just do models that help you kind of wrap your head around the geometry and what's happening. So I just wanted to touch on that a little bit, the amount of applications that we do. The other thing I want to touch on, Pat kind of mentioned being able to pause the printer and being able to do inserts inside of a part. So if you want metal threads or if you want to insert a component inside a part, it's really easy to do. The Markforge, all the Markforge lines of printers use a phenolic build plate, which is very robust and it's extremely flat. And if I pause the build here, you'll see just how easy it is to take out the build plate. The build plate uses 3 thumb screws on the bottom for micro adjustments for leveling the build plate. It also uses magnets in combination with that and the screws on the bottom to locate the build plate. So whenever you take parts out and you're going to be doing any kind of component inserting, to be able to really quickly take it out, get done what you need to get done, and put the build plate back in is really nice. And the way the system is set up, we have a 10 micron repeatability. So you don't have to worry about taking the build plate out and that build plate or the print actually losing accuracy. You know that when you put that build plate back in, it's going to be exactly where it needs to be. The other thing I want to point out is the printer doing verification strips on the top and on the right. What the printer does is, Matt had mentioned that the printer has a laser for 3D scanning. It will scan the bed for level, and then it also does some test prints over here on the right. And what it's doing there is it's actually scanning the width and thickness of the bead that it's laying down to make sure that it's actually purging and printing material appropriate for the layer resolution that you're printing in and the quality of the material. And again, that's just a step that it's taken to try and give you the best foundation when you start printing a part to make sure that you're going to have a successful build. And that's kind of what you get with Markforged in the industrial series. You really get a reliable machine, something that's really just press, print, and go. You don't have to worry too much about fiddling with the machine and adjusting the build height and leveling the build platform. For the most part, the Markforged line of printers, they do that for themselves. So really good machine. I'll kick it back to Pat to close it out. If you have any questions, if there's something I didn't show you want to see on the machine, or you have a specific question about how to do something on the machine, type those in the comments and we'll be able to address those questions.
Okay, thank you, Anthony. Very good. You have a couple of questions. One, Pat, if you want to take. So the question is, when you pause the printer to add an insert, is there support material in the void they have to remove, or can the printer be told not to print the support material?
Sure. So, yes, it depends, basically. If your part does not require supports anywhere else on your part, you can tell the software to just not use supports, and it won't fill those void cavities with support material. If, on the other hand, elsewhere on your part support is required, then those cavities will be filled with support material. Right now, we do not have the option to selectively tell the software where we want supports and where we don't. It's kind of binary, so it's either going to be on or off. But we've certainly done it such that the supports are removed from the cavity, and I mean they come out within a second or two. It's very easy to pull those out and drop in those inserts. We do just usually recommend when doing that we add a few thou clearance in X, Y, and Z just to make sure that those fit in nicely and that they're either flush or recessed to that last layer so that you don't run into any type of collision with the head.
Right. Yeah, it's very helpful that you can take out the print bed when doing that. Okay, the next question is, how much does a carbon fiber filament cost compared to unreinforced? So basically, the unreinforced onyx, the 800cc spool that Anthony was talking about, that's $190. And then if you were to take the carbon fiber at the 50 filament or the 50cc spool, you're at about $150. And if you take fiberglass, which is the least expensive for the same amount, 50 cc's, you're $80. So it does depend on the fiber filament, and it does add cost, obviously, to add the fiber reinforcement. However, you don't need a lot of the fiber to really make the part strong. What we found, that works well is like the sandwich panel, a group of fibers at the top and in the middle at the bottom. It really depends on what your application is, but what we found is that you don't usually need a lot of fiber, to reinforce the part and make it strong. It's maybe like 90 to 95% of the material is going to be the onyx material. Hope that answers the question there. Anything else? Any other questions for the team here? Anything on the actual machine or the software? Okay, well, with that, we thank you very much for your time. It's much appreciated. And come back and hear us on Thursday for our metal webinar. We'll be showing the actual machine that we have here in the office, and look forward to seeing you then. Thank you, everyone. Have a great day.
Thanks for your time, everyone.
Thank you.